In this class, we're going to study Lesson 3 of Modern Arithmetic 4. Lesson 3 of Modern Arithmetic 4, and in Lesson 3, we're going to study Articles 40 through 50. Articles 40 through 50 in Ray's Higher Arithmetic. So let's take a minute, get our notes ready. Put your name and date at the top of the paper. The name of the course is Modern Arithmetic 4. This is Lesson 3. And the topic is numeration and notation. Is that right? Numeration and notation. Is that what it says at the top of the chapter? None of you hear me? Oh, you don't have it in front of you? Yeah, that's it. Numeration and notation. Okay, so Lesson 3, numeration and notation, and that's Articles 40 to 50 in our textbook. In the first few lessons, first few classes, we went through all of the different definitions, signs, and symbols of arithmetic. And those lessons are helpful for your study of arithmetic in general, just because it's the language of arithmetic. But even more importantly, those are the definitions and signs and symbols explained by the author of this book that he intends to use throughout this book. So as we go through this study of this textbook in arithmetic, you should take time now and then to flip back to those first chapters and just check on the words and the definitions and the signs and the symbols and make sure you remember how he defined them at the beginning of the course. Remember, in reasoning, we're learning about how words have different meanings and that causes confusion. Well, the same thing will happen if an author of a book gives you definitions up front and says, these are the definitions for the words as I'm going to use them in this book, and you don't study that carefully, your confusion is your own fault, because the author went out of his way to make things clear in the beginning, and you have to make the effort to look at his list of terms and the definitions that he provides, the signs that he says he's going to use, and symbols, and you need to make sure that you keep those things in mind to avoid confusion. In this lesson, we're going to really get started with the study of arithmetic at this level, Arithmetic 4. Now, one of the dangers in this course is that a lot of this material is going to be familiar to you. And I say that's a danger because you're going to look at a lesson quickly and you're going to say, oh, I know this stuff. But obviously the author of this textbook, writing an Arithmetic 4 book, knows that everyone taking this course already knows a lot of this stuff, right? The author knows that. He didn't make this book just for the fun of it. He introduces more detailed definitions. He introduces more information, and he's working to lead you to a more perfect mastery of arithmetic than you have so far. So just because things look familiar, don't be arrogant and think you already know these lessons. Because there's content in these lessons that you have not studied before, and that's the most important part of the lesson. Do you understand that? Okay? The author knows you've already studied Arithmetic 2 or 3, and now this is Arithmetic 4. He knows you already know a lot of these things, but he's seeking to teach them more completely in Modern Arithmetic 4. So assume that you don't know the content of these lessons and study them carefully, and you'll have a more perfect knowledge of arithmetic. And no matter what math you're studying, if you're in algebra class, your lack of knowledge of arithmetic may cause you to struggle in algebra. So let's make sure we study arithmetic carefully, not only for the sake of using arithmetic in life, but let's also make sure we learn all the principles and all the rules so that when we go to algebra and try to get into higher maths, we're not held back because we really don't understand arithmetic. Okay, so a lot of this stuff will look familiar, but the important parts of these lessons are the little bits of additions that he makes where things get clearer and more complex. All right, so Articles 40 through 50, we're going to read through them together and we'll comment as we need to as we go along. So let's look at the textbook. Article number 40, we learned the definition of numeration. Article number 40, we learn what numeration is. One of the words from the title of the lesson, numeration. Numeration is the method of reading numbers. Numeration is the method of reading. Reading is the key word. Reading numbers. Numeration is the method of reading numbers. Numeration is how we read numbers. It's basically in arithmetic what orthography would be in grammar. Numeration is the method of reading numbers, how to read and understand numbers as they're written in words or with figures. The second definition in Article 40 is the definition of notation. So we have two definitions in Article 40. Numeration and notation. Notation is the method of writing numbers. Notation is the method of writing numbers. And everyone will say, oh yeah, I know how to do that, but this is the stuff kids get wrong in algebra class. This is the stuff that kids end up getting SAT questions wrong for, getting lower grades on tests because they're careless and they get simple arithmetic issues wrong. This is the kind of stuff that keeps kids back from getting A's in math classes. Numeration is the method of reading numbers. Notation is the method of writing numbers. Numeration is the method of reading numbers. Notation is the method of writing numbers. Reading and writing. Numeration and notation. In order to write numbers, we use words, letters, and figures. Words, letters, and figures. So in numeration, we learn how to read the words, letters, and figures that are used to write numbers. And in notation, we learn how to write the words, letters, and figures that are used to express numbers. Okay? Then in Article 41, we have these simple number lessons, these simple lessons. We learn the names of and figures of the first 9 numbers. Okay? The first 9 numbers are represented by a single figure. So we learn the figures of Arabic numerals in Article 41. And of course, the author of this book knows that you know these things. All other numbers are represented by combinations of these and another figure, 0. So what's important to learn here, we have the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. These are basically the letters of the alphabet of arithmetic. Right? In English, we say there are 26 letters. In Latin, there are 23 letters. In Greek, there are 24 letters. In arithmetic, there are 10 figures. Every number that can be imagined can be expressed using only these 10 figures. And while you may think this is baby work, this is really the most amazing thing about our system of arithmetic. We can express any number from 0 to billions of numbers and only need to learn 10 characters. That's pretty amazing that a system of numeration and notation can exist where you can write millions or billions of numbers and only need to know 10 characters. Can't get much simpler. We have a note in the book under Article 41 that says the 0 is used to indicate no value. So the 0 is used to show that an order, we're going to study orders in a minute, a 0 is used to show that a certain order is simply empty. Okay? All the other figures that are used are called significant figures. Significant figures. So know the term significant figures. You'll see this in science classes. Significant figures. In science classes for short, sometimes these are referred to as sig figs. Significant figures. Sig figs. So if you have a number like 43,260, and you're asked how many significant figures are in that number. How many significant figures are in that number? No, 4. Numbers other than 0. Okay? Significant figures have to do with orders. This is the units, this is tens, hundreds, thousands, and 10,000s. How many units are there? 0. Okay? This is not a significant figure. It's simply a sign that shows us that there's nothing in that order. Okay? But these are significant figures. They show us that there are values in these other orders. Okay? So a significant figure is a number other than 0 that's used to make up a number because it shows us that there are a certain number of those units in this number. Okay? Let me just show that again because I'd like to show it on the video. If we take a number, when we talk about significant figures, if we have a number like 589,070, we take a number 589,070 and we're to understand, based on the way that our number system works, that each of these numbers represents a certain number of units. In the first column here we have units, in the second we have tens, in the third we have hundreds, then thousands, then 10,000s, then 100,000s. These numbers are only rightly understood if we think of this system of orders and different units. So when we look at this number, this 0 simply tells us that there are no hundreds. And this 0 tells us that there are no units. So these are not significant figures, they're just placeholders. Make sure you follow me here. Understanding this is the kind of stuff modern students don't learn and why they never really understand mathematics. These zeros are not significant figures, they're just placeholders. All of the other numbers are significant figures. This is significant because it tells us that there are 500,000s. This is significant because it tells us that there are 8 10,000s. This is significant because it tells us there are 9,000s. And this is significant because it tells us that there are 7 tens. This is not significant. It's simply a placeholder. There are no hundreds. This is not significant. It's just a placeholder. There are no units. So if we were to ask in the number 589,070, how many significant figures are in that number? What's the answer? 4. Okay? 1, 2, 3, 4. There are 4 significant figures. All right? 0 is really not a number. It's just a placeholder in this system of numeration and notation that we use. You understand that? 0 is just a placeholder. The other numbers are significant figures. The word significant just means they're meaningful. They have meaning. These numbers have meaning. Zeros don't have any meaning. They just hold an empty place. All right? Article 42. The next higher number than 9 is named 10, and it's written with 2 figures, a 1 and a 0. The 0 simply serves to show that the unit on its left is different from the unit 1 standing alone, which represents a single thing, while this, 10, represents a single group of 10 things. And so it's important for us to make sure we understand our system of numeration and notation expresses numbers by use of what are called place values. This is the wisdom of our numeration system. What makes it so amazing and useful is that you can barely know any characters, 9 different characters, and you can express any quantity, any multitude. The first 9 numbers we learned here, 1 through 9, and then once we pass 9, we get up to 9. When we add one more, we move from 9 units to 110, and we simply put a 0 to show that there are no units beyond that 110. We express numbers using place values with only 9 different characters. Okay? And if our numbering went up, if our numbering continued, and we went from 10 to 11 to 12 to 13, 14, 15, 16, 17, 18, and then finally to 19, we would have filled up the units column, and if one more was added, we would remove those 9 and add another 10, so we'd have 2 10s and no units. And again, you take this for granted because you just do it, but what I want you to see is how wise and useful this system is, right? Remember when we had literature class and I said, you often read a book and you just get lost in the story, but you don't pay attention to the fact that a man created this story. The same thing is true in mathematics. You just do this. You just talk about numbers and write numbers, and you take it for granted without realizing that men actually invented this system, and it makes numbering so easy that if you have 9 characters, you can express any number. It's a brilliant system for numeration and notation, and there's no way you could possibly make it any simpler. If you try to use Roman numerals, you'll see how ridiculous that seems compared to our system of numeration. Okay? So we take this for granted, and everybody will think this is simple and say, yeah, no duh. But this is actually what's most amazing about our arithmetic system, is the way that we write and read numbers is so easy that we can express any number with just a few figures. So in Article 42, we go through the names of the numbers from 10 up through 20. One second here, I'm going to reload my book. So looking at the bottom now of Article 42, we read, in each of these numbers, 11 through 19, in each of these numbers, the one on the left represents a group of 10, while the figure on the right expresses the units or single things that are added to the tens to make up the number. That's Article 42. How to compose the numbers 11 through 20. The next number above 19 is 10 and 10. So since 19 would be 110. 19 would be 110 and 9 ones. The next number would be 110 and 10. So it would be 2 tens. This is written with two tens and 0 ones, and it has its own name, which is 20. And then the tens after 20 have their own names, 30 and 40, 50, 60, 70, 80, and 90. And they're written to express the different groups of tens, and then the numbers of units added to them are written with the characters 1 through 9 in the units column. So the highest number that can be written with two figures is 99, which contains 9 tens and 9 units. And if we go up, we have 100, and then the hundreds go up to 1,000, and you know these things. But what I want to make sure you focus on, is that the way that our system of arithmetic is designed to work, you're supposed to think of numbers in terms of different columns or orders of values. So when you have the number 352, if you have the number 352, you can think of this as 352 units, but you're going to struggle to work with this number if you think of it in that way. And that's not how our numeration system works. What this is really telling you is that you have a quantity, and that quantity contains 3 hundreds, 5 tens, and 2 units. And so if you're to add quantities like this, and if I were to say to you, add 352 plus 436, you would sit there and say, I can't add that, I have to write it out or use a calculator. Because you think of these numbers as units, 352 units plus 436 units. And that's not how you should think of them. You can add these very easily if you think of them in place values. Because all you have to do is add the figures in the place values. So if I have 300s and 400s, I have 700s. If I have 5 tens and 3 tens, I have 8 tens. And if I have 2 units and 6 units, I have 8 units. I can easily add this in my head. 300s and 400s make 700s. 5 tens and 3 tens make 8 tens. 2 units and 6 units make 8 units. That makes the number 788. If you learn to think about numbers in terms of place value, the numbers become very simple. This is why when you're memorizing math facts, you only memorize 1 through 9, because that's all you need. Because we simply add different places separately. All you need to know is what is 3 plus 4? What is 5 plus 3? What is 2 plus 6? That's all you need to know to add hundreds, thousands, 10,000s, millions, billions, on and on. 9 characters, simple math facts. Article 43, we learn the definition of an order. Article 43, the definition of an order. What is an order? An order is, or the order of a figure is the place it occupies in a number. An order is the place a figure occupies in a number. The order of a figure is the place it occupies in a number. And our text reads, "From what has been said, it is clear that a figure is in the first place with no others to the right of it and expresses units or single things. But standing on the left of another figure, that is in the second place, it expresses groups of tens. Standing to the left of two figures, or in the third place, it expresses tens of tens, or hundreds. In the fourth place, it expresses tens of hundreds, or thousands. Hence, continuing from the right hand, the order of units is in the first place, the order of tens is in the second place, the order of hundreds is in the third place, the order of thousands is in the fourth place. By this arrangement, the same figure can have different values according to the place or order in which it stands." This is the real brilliance of our arithmetic system. By this arrangement, the same figure, we only need 9 figures. The same figure can have different values according to the place or order in which it stands. That's Article 43. Article 44. The word units may be used in naming all the orders as follows. So when we have a number, let's say 4,326, we call this the units place, we call this the tens place, we call this the hundreds place, and we call this the thousands place. But we refer to all of these as units. 2 units of tens, 3 units of hundreds, 4 units of thousands. Okay, and in Article 45, we have a table that shows all of the orders, all the way up to hundreds of trillions. Okay? Hundreds of trillions. And it's obviously very rare to deal with those numbers. But it's important for you to know that it just goes units, tens, hundreds, thousands, 10,000s, 100,000s, then to millions, 10 millions, hundreds of millions, then to billions, and then to trillions. Okay? So you should understand the names of the different orders up to hundreds of trillions. That's the point of Article 45. Article 46. For convenience in reading and writing numbers, orders are divided into groups of 3. For the convenience of reading and writing numbers. When you think of millions and billions and trillions, you can imagine that numbers can become very difficult to read, right? If we have a number that you read if you look at that number in a book and have to read it, how would you even begin? It's very difficult to read, right? When there's just a whole string of figures in a number. You can read that. Nothing else is necessary. You can read that. But it's not convenient. It's not convenient to read numbers like this. So the orders of our numbers in arithmetic are divided into periods, we're told. And a period is every 3 place values. Okay? And every period is marked by a comma. So now if you look at that number, with commas dividing the periods, the number is much easier to read. You can see that these are hundreds. Here we have hundreds of thousands. Here we have hundreds of millions. And the first figure in this number expresses billions. That's what's actually difficult about reading the number. When you saw this long number written on the board, you didn't know what order this was. You didn't know if it was 300 million, or if it was 3 billion, or if it was 30 billion, or if it was 300 billion. You would have had to go back here and count to figure it out. Do you understand that? You wouldn't have been able to read it. But when we mark the periods with commas and we mark every 3 orders, it makes it, especially if we get a little experience, it makes it very easy for us to quickly see what order we start with, because we have to start with this order to read this number. So just another example, if I had 8, 9, 6, 5, 4, 8, 2, 9, you wouldn't know how to read that number. You wouldn't be able to start reading it. You would have to first stop, go back to the beginning. Pay attention with me. You'd have to go back to the beginning, and you would have to figure it out yourself. You'd have to say, okay, that's units, tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 million. You'd have to figure that out. So this is 10 millions place. So this is 89 million. But if that number was written with periods, it would be much easier to see. You see how much easier that is? When the periods are marked out with commas. And when you get experience with it, you learn very quickly that the third period is millions. The second period is thousands. The fourth period is billions. The fifth period is trillions. You learn to recognize it very quickly. So numbers, especially when they get beyond thousands, they're marked in periods just for convenience in reading. It says, for convenience in reading and writing, orders are divided into groups of 3, and each group is called a period. So there's the units period, the thousands period, the millions period, the billions period, and the trillions period. And they help us to read and write numbers more conveniently. Are they necessary? Are the commas in numbers necessary? No. If you're typing in a computer or in a calculator, you don't need to write any commas. The computer doesn't need commas. Calculator doesn't need to have commas. But if you're writing for other people and they have to read the numbers, adding marks for the periods is very helpful. It also helps you to make sure you don't miss anything. Okay? So that's Article 46. In Article 47, we read, it will be observed that each period is composed of units, tens, and hundreds of the same denomination. So every period contains units of the same denomination. This period here, the first period, is called the units period. The second period is called the thousands period. The third period is called the millions. And what this Article 47 is telling us is that each period contains units, tens, and hundreds of that denomination. Units, tens, and hundreds of that denomination. Units, tens, and hundreds of that denomination. So each period can be thought of as a collection of units, tens, and hundreds of each of these units that are marked by, or denominations that are marked by each period. That's Article 47. Article 48. Article 48 simply lists the periods for us all the way to the 10th period, which is octillions. And you will never ever need to learn or know or use these numbers. And it even goes further than that and goes through the next 12 periods all the way up to vigintillions. Vigintillions. Now, those numbers are impossible to understand, right? Billions, trillions, quadrillions, quintillions, sextillions, septillions, octillions, nonillions. unless you know Latin. If you know Latin, you don't need any help understanding those numbers. Millions, we start with, then billions, and what does bi mean? Okay, 2, right? So it's the second order or second period past millions. Then the third period, tri, is third. The fourth period is quad, and then quint is fifth, and then sext is sixth, and sept is seventh, oct is ninth, and it just eighth is it just goes on. Okay? So if you knew that septendecim was the number for 17 in Latin, septendecim, that's 17 in Latin, you would have no problem understanding what septendecillions are. Right? It's 17 illions. You got that? So those numbers can be confusing unless you know Latin. If you know the numbers in Latin, all of those names are just very simple. Okay? So they go all the way up. The periods go all the way up. The different units they express. We can go on and on and on. But you see the names of those different units are simply taken from Latin numerals. All right? So at the end of all of this, in Article 48, we have a list of principles. And the principles are what's important. So let's pay attention to the principles. Like I said, in this course, you're going to know a lot of this stuff because this is simple stuff. But what we're going to do that's more mature, that's more perfect in your studies is focus on principles. And here in Article 48, we have 3 principles listed. The first principle says 10 units of any order always make one of the next higher order. That's principle 1. 10 units of any order always make one of the next higher order. And we should write these out so you get them in your notes. The principles written in Article 48. Principles of numeration. Of numeration and notation. Principle number 1. 10 units in any order always make one of the next higher order. 10 units in any order make 1 unit of the next higher order. That's principle 1 of numeration and notation. 10 units in any order make 1 unit of the next higher order. And by higher, it means to the left. 10 units of any order make 1 unit of the next higher order. And we can easily see that if we have 9 units and we have 10 units, 10 units of any order make 1 unit of the next higher order. So to go from 9 to 10 makes 1 unit of the next higher order and leaves no units in that first order. That's expressed by principle 1, and it applies to all of the orders. 10 units in any order make 1 unit of the next higher order, that is the order to the left. Principle number 2. Removing a significant figure one place to the left increases its value tenfold. Removing a significant figure one place to the left increases its value tenfold. Removing there means moving. Okay, removing doesn't mean taking away, it means moving. Removing a significant figure one place to the left increases its value tenfold. So let's not use that word removing. Let's use moving a significant figure one place to the left, increases its value, the value of that figure, by 10 times. Moving a significant figure one place to the left increases its value 10 times. What that means is if we have the number 356, and we say 6 is in the units place, 5 is the tens place, and 3 is in the hundreds place. If we were to move this 3 to the next higher order and write 3056, the value of this number would multiply by 10. That's what principle 2 means. If we move a number to the next higher place by moving a significant figure one place to the left, it increases its value by 10 times. Okay, that's the first part of principle 2. The second part reads, one place to the right decreases its value by tenfold. So one place to the right decreases or divides its value by 10 times. So if we took this number 3 in the thousands place and moved it to the right and wrote the number 356, this number 3 would have 1/10 of the value that it had in its previous place. So if we move a number to the left, it multiplies by 10. If we move a figure to the right, it divides by 10. Just a principle. It's just a principle of how our numbering system works. And the third principle, vacant orders in a number are filled with zeros. Vacant orders, that means empty orders, are filled with 0. Vacant means empty. If you drive past an apartment complex and you see a sign out front that says vacancy, it means that there are open apartments that you can rent. If you drive past a hotel, at least back in the old days, they don't really do this now with computers, but there would be a sign out front that said vacancies, and that meant that they had open rooms, they had empty rooms. So in Article 48, we learned three principles that really explain this whole system of numeration and notation. So the point of this lesson is really to lead us to these three principles. This is a summary of this whole system of numeration and notation in arithmetic. Anybody have a timer going? What do you got? 44? Okay. So these three principles summarize this whole system of numeration and notation. These principles are the difference from being a person who simply uses the numbers to being a person who has a scientific knowledge of the numbers. You understand the difference? We all know how to write numbers. We pick it up just by experience. But to know the principles of the system of numeration and notation, to know the principles of the system, to understand why different numbers mean different things, to understand how the numbers are expressed. That's scientific knowledge. That knowledge is only possible if you know the principles. Okay? That's the goal of our studies, to know principles. And we have 3 principles there in Article 48. After that, there's a problem to solve. They give you a number, and they give you this long number, 10 or so digits. And they say, express in words the number which is represented. And they give you these numbers. Let's do it together. So here's a problem for us to solve. And you can see, if you see the numbers in the book, there's no marking of the periods, there's no commas, and you can see that it's hard to read. 60892 1045. 60892 1045. That's the number in our book, and we're asked to express this number with words. All right? And you can see, looking at the numbers, it's difficult to do that. We have to figure it out. Okay? So the first thing we can do to help ourselves is mark out the periods. So we can say, we're going to mark every period with a 0. So there. Doesn't that make that number a lot easier to understand now? It's 608,921,045. Once I see the periods, I can easily read it. Okay? You can't, because you have to gain experience with this. But when I see the periods, I can quickly tell that that's 608 millions. Because it's the third period, 1, 2, 3. This is units, this is thousands, this is millions. So when I see these figures are in the millions period, I can quickly read it. 608,921,045 is how that number is read in words. Okay? So we have principles of numeration and notation. We see the challenge of reading numbers that express greater quantities than we usually work with. And we see that there's a method for doing it. When you see some long chain of numbers, the first thing you should do is mark the periods. Once you mark the periods, then you can see the units, the thousands, the millions, the billions, and it makes it much easier to read. Okay? Next in our lesson here, we find a rule for numeration. A rule for numeration. So I'm going to erase these principles. A rule for numeration. And the goal of our studies, like I said, is not just to learn how to do things, but to learn to understand why things are the way they are. To learn rules that apply to all situations. Not just to learn specific solutions to problems, but to learn rules and principles that apply to all problems. And in Article 48, we have a rule for numeration. The rule has 2 steps. Step 1, begin at the right and point the number into periods of 3 figures each. So rule 1 is to mark out the periods. Point the number into periods of 3 figures each. And then the second step, beginning at the left, read in succession each period with its name. So the name of this period is millions. The name of this period is thousands. The name of this period is units. Read the number 608,921,045. Okay? That's a rule for how to read numbers. Step 1, mark out the periods and think of the names of the periods. Step 2, read the number in each period. It's a 3-digit number. Read the number in each period and then say the name of the period. And that's how you read numbers in our system of numeration. Very simple. Mark the periods, then read from the left. Read the 3 numbers in each period, and then the name of the period. That's all in Article 48. Okay? We're then given other problems to solve, other numbers, some of them really huge. I'm going to leave that alone. So you have problems to do. What's significant on the end of the next page, so this is page 26 in the textbook, we have a rule for notation. Find that. You see that there are problems listed, but then there's a rule for notation. The rule for notation: begin at the left and write each period in its proper place, filling the vacant orders with ciphers or zeros. To write numbers, begin at the left. So when we write numbers, if we have to write 700,256, and we have this line to write on, we don't start over here to write numbers. We start over here. We start with the 700,256. So in notation, we write from left to right. Just about everyone does that, so we really don't need to learn it as a rule, but nevertheless, we have the rule for notation. Begin at the left, write each period in its proper place, and fill the vacant orders with ciphers or zeros. There are then more exercises to do. On page 26, they go down onto page 27 of the document. And then in Article 49, we learn the English method of notation, of numeration. In the English method of numeration, 6 figures make a period. So this is a different method. The English method of numeration, 6 figures make a period. The first period is units. The second period is millions. The third period is billions, then trillions, and so on. So there are simply no thousands. Okay? The first 6, all the way up to hundreds of thousands, are called units. And then we have all the way up to hundreds of thousands of millions, then hundreds of thousands of billions, then hundreds of thousands of trillions. I don't know anyone who uses this method, so it's really just helpful, I guess, for the sake of some history or trivia about numeration. So you may encounter that in a book, but know that there's another method known as the English method of numeration. And then lastly, in Article 50, we have the system of Roman notation. What I'd like to do is, there's a lot of content in this lesson. There's a bunch of exercises to do in this lesson. And then we have this whole lesson in Article 50 about Roman notation. What we're going to do is stop this lesson here. In our next class, we're going to review this lesson, go over all the exercises together, and then also study Roman notation. Okay, so we'll do that in our next class. So that's all for this, we'll say, part 1 of lesson 3. What I'd like you to do is take a few minutes, not take 3 seconds, but take a few minutes and write a summary of what we talked about in this class. Remember, these summaries are for you. They're to help you remember what we studied in this class, so you know what these notes were about. Where you can find this in the book, make sure you connect your notes to the book so you know where to find this information in your book, and also to the video. So if you want to review a video, you can easily remember which video it is that you need to look at. All right, so that's all for the first part of Lesson 3 in Modern Arithmetic 4.